I would now like to discuss the plot viewer within SVS. To do this, let's start by opening some association test results. In a later video, we will show you how to perform the analysis that generated these results. Notice we have p-values, minus log 10 p-values, test statistics, all from the correlation trend test. These are the data we'll be plotting today. In SVS, you can plot many things. There are icons across the top of the spreadsheet for certain kinds of plots. Variables in Genome Browser, scatter plots, histograms, LD plots, heat maps, and variant maps. We can also access these from the Plot drop-down menu. In this case, let's plot variables in the Genome Browser, and we'll plot the minus log 10 transformed correlation trend p-values. This should produce a nice Manhattan plot. I'll check the box and click Plot. The results are drawn in genomic scale. First, let's discuss the layout of the plot viewer. Here we have our graph item, the data within this graph, our full domain view, which will always give us an idea of where we are zoomed into on the genome, our annotation tracks below, the graph control interface, and menus specific to each graph item, and a data console. The user graphs level controls the entire plot viewer. You can see the menus allow us to add plots from the existing spreadsheet or add plots from an additional spreadsheet. The next level down is this particular graph item. Let's turn on a title and rename this. Notice we can change the axis labels and add additional items into this graph. The next level down are the data elements within the Manhattan plot. Here we can change things like symbols and lines, colors, how things are smoothed, how things are filtered, and we can color the data. We can change the uniform color or color by variable. Let's click this color by variable radio button and select our chromosome variable. Now, let's zoom into the result that we see here on chromosome 6. To zoom with an SVS, you can click and drag a box. You can right-click and zoom in at an X factor or out. You can also undo or reset the zoom. But my preferred way to zoom is to click below the horizontal axis and draw a window around the location of interest. The more you zoom, the more detail you'll get. And notice, as we zoom in, the genes drawing below in the annotation tracks expand as well. Up above in the full domain view, you can see precisely where we are in chromosome 6. I'm going to close this part of the plot viewer out to give us some more vertical space. Let's now add an additional annotation track by clicking the annotation track item in the graph control interface. The first tab pulls from our fully cloud-enabled data server. The second tab contains our locally hosted annotation tracks. In this instance, let's load data from the database of genomic variants. By clicking on a section of the annotation, we can see the additional data contained. Let's hide this annotation and add an additional plot type to this plot viewer instance. I'll scroll back to the top and click on User Graphs. I would now like to add an LD plot. I will use a different spreadsheet, one containing the genotypes, to build this LD plot. Notice that we now have R² for linkage to equilibrium plotting in the same space as our p-values from above. This is quite interesting, and I would like to save this plot to send to a collaborator. To do so, I'll go to the File menu, select Save PDF or Save Image, specify how big or small I would like this plot, and click Save. Let's quickly look at some of the other types of plots SVS can create. I'll open up the phenotype and genotype dataset we worked with in the previous video and investigate one of the phenotypes further. For example, let's look at phenotype 2. It is real valued data, and I would like to know how it is distributed. So I will right-click and select Plot Histogram. I can now click on the graph item and increase the bin count for more resolution. Let's expand this project to look at a heat map. This is a heat map of identity by descent values. Let's now open a different project containing sequencing data to look at a variant map. I'll open up a file containing sequencing data. Notice when I expand the map field, we have a reference allele. When you have a reference allele, you can plot your variants across the entire genome. Each colored block represents a variation as different than the reference. To make this easier to view, I'm going to now split this by family and color by affection status. And zoom in. Here we have a variant in an unaffected parent that is shared by an affected child. As you can see, the PlotViewer is very powerful, and you can do many things, including adding additional plots, adding additional data to existing plots, zooming, scrolling, and adding public annotations to help enrich your visual experience.